being used. It is being used for what? Ant colony used for finding the shortest distance, shortest time. Ant colony optimization, the behavior of the bird, as you see, the birds start moving randomly to find the food. When they find the food, they follow a path, and that is the shortest path. Each ant spray liquid called pheromone, and other ants smell this liquid. Wherever the liquid smell is there, they follow that path, and that becomes the shortest path. Many of the transportation problem, communication problem, digital communication problem can be solved by ant colony optimization. The behavior of the bacterium, bacterial foraging optimization. To my knowledge, there are 50 types of such algorithm. Population-based cooperative learning has come and very powerful. Unfortunately, try to remember this. Unfortunately, these algorithms are time-taking. These are population-based learning. It is not a single solution. You got a set of solution, and you have to find the best out of this. Time-consuming. Therefore, it cannot be used for online purpose. For real-time solution, it cannot be used. But today, distributed learning, try to note down what is distributed learning, diffusion learning, incremental learning. These types of techniques are being employed for solving this. So this is biologically inspired technique. There are various types of performance measures when you develop a model by training, either by machine learning or deep learning. You have to evaluate the performance of that model. There are two models. Which model is better? Support vector machine is better, or NAP-Bayes is better, or neural network is better. You have to find the accuracy. You have to find the sensitivity. You have to find the specificity. Then you have to find the false positive rate. You have to find the false negative rate. Then the ROC curve, and therefrom you will find area under the curve, AUC, root mean square mean amplitude deviation. So these are the various performance measures. When you compare, you can find out the two methods, which method is better than the other. Of course, the performance of the method not only depends on the model, also the amount of the types of data that were injected. If the data is changed, the model behavior change. So it is data dependent. Now, as I told earlier, the various applications of artificial intelligence and machine learning, healthcare, prognosis, diagnosis, development of expert system, prediction of disease, classification of disease. This can be used for finance, stock market, exchange rate prediction, interest rate prediction, portfolio management, and so on. It is used for agriculture, commodity price prediction, evaporation rate prediction, for pollution and weather, for forecasting and classification, multimedia application, speech enhancement, image compression, denoising, noise estimation, recognition, understanding of speech, IoT, sensor network, cloud computing. Today, for security, the machine and deep learning techniques are extensively used. Power engineering, that is used for smart grid, protection, distribution, and generation. All machine and deep learning techniques. Manufacturing, intelligent sensing, intelligent instrumentation, secure data transmission. For communication, cognitive radio, spectrum management, smart antenna, spectrum allocation, channel equalization, classification of wireless signal, etc. E-governance, for decision making, public welfare, and so on. For smart city, deployment of smart sensor, traffic management, pollution control, water and electricity management, etc. we use all machine and deep learning techniques. So this I have already told. In the intelligent computing, as I said, these techniques are there. But I'm only giving you the information I must have used earlier. These techniques, as I told, genetic algorithm, survival of the human being, how we are monkey, and from monkey become intelligent person. So there is a lot of change has taken place. So this genetic algorithm is the first of its kind of biologically inspired technique. And these techniques, genetic algorithm is still very popular. The multi-objective genetic algorithm called NSGA, non-dominated setting genetic algorithm, is used for solving multi-objective problems. The various applications of GA, all types of optimization, robotics, signal processing, semiconductor design, automatic programming, and so on, hundreds of applications. Particle swarm optimization is the behavior of the bird. The bird moves from place to place to search for food. And if one bird finds a food, all other birds which are they are at different places, they migrate to the same place to take the food. How do they communicate? So particle swarm optimization based on P-based and G-based, global-based and personal-based, they are employed to solve the problem. PSO is much better than J because it takes less time and more accurate. This is the behavior of the bird. It started in 1995 by Everhard and Kennedy. The bird's behavior. They move, search for food, move with high velocity. But when they find a food, their velocity reduces, they become steady. And if one bird finds a food, all other birds come to that place, either during good time or bad time. And this set of bird is called swarm. So it is a swarm intelligence. And these techniques had a lot of potential application. I'm not going in detail into this algorithm. So actually, there is a velocity update of each bird at each time, and then the position update. So all birds at different place, but finally they come to one place where the velocity becomes zero, and all occupy the same position, and that is the solution. This cat's behavior have been employed for solving very powerful problems. It is better than cat swarm is a better than bird's behavior, particular swarm, much faster. And this started in Chu and Sai in 2007. And those who are using PSO better to use cat swarm their behavior. The cat has two behavior. Mostly they will be sleeping at a place, and suddenly when they find a food source or an enemy, they start running very fast. Two behavior. And these two behaviors are being used for solving the problem. Cat swarm optimization is very, very important. And one is called seeking mode of the cat, other is called tracing mode. And these two techniques are being used as a hybrid algorithm much faster than PHO. Ant colony, I told, you see the birds move, the cats are moving, the ants are moving in different positions. And when there is a hindrance or obstacle, this bird returns. This fellow finds another path. Somebody goes in a roundabout path. But once they find a food source, they come to the nest by a single path. So this is, as I told you, they spray a liquid called pheromone, and that liquid is the basic fundamental. Depending upon the intensity of that liquid, they select the path. We try to solve many problems using this different algorithms. We have published many papers, maybe more than 50, 60 journal paper for various applications using biological inspired technique. I'll give you a list of our publication which my doctoral student have done. Yes, using these types of algorithms. Now for classification tasks, support vector machine, hidden Markov model, nearest neighborhood classifier, deep learning models. We apply for currency exchange rate. Prediction of $1 is how many rupees, $1 is how many pound, how many yen. So we develop predictor, short time predictor and long time predictor. You can predict for tomorrow or you can predict after 7 days, any currency. So those who are interested for finance, we did a lot of work on this in the past. And the list of publication I will keep it. Now coming to the deep learning models. Deep learning. Yes, there are varieties of deep learning algorithms. I'll give an overview. Basically, the deep learning models, it is called deep because there are many stages of learning. Inner and inside. One, you make some rough decision, let an improved decision, and finally you get for the most accurate decision. Now this deep learning, varieties of algorithm. There are about 15 such deep learning algorithms. I have listed here, it is a old slide, 11. Convolution neural network, LSTM, long short-term memory network, feed-forward neural network, recurrent neural network. The most important among this is fifth one, generative adversarial network, GAN. I'll tell something on the GAN. Radial basis function network, multi-layer perceptron, self-organizing map, deep belief network, restricted Boltzmann image, auto-encode. Each one at least take half an hour to get the fundamental. But out of these, the most innovative one, CNN is the most common one, everybody is using. But the powerful one is the GAN, deep belief network, restricted Boltzmann machine, and autoencoders. The fundamental of CNN, three parts. One is convolution layer, other is pooling layer, other is output layer. Can you tell me what for convolution is used? Convolution is used for what purpose? There is no interactive, so very difficult to make you convince. Convolution is a type of filtering. Convolution is used to extract the feature. The redundancy, the unwanted things are suppressed and the features are extracted. Convolution is just like signal plus noise. The image is contaminated noisy image. You have to get back the image. It is a two-dimensional filtering. So that is a two-dimensional convolution. So by using set of convolution from layers to layers to layers, you get, I'll give an example. A tree you are feeding to the model. Tree will be split into stems, roots, branches. This is raw feature. Again, from the branches, you go to the leaves, slightly better feature. And from the leaves, you are going to the different sub-portion of the leaf, inner part of the leaf. That is the refined feature. So this way, a set of convolution operations are performed, series maybe 100 times or 200 times or 50 times to get the good features. And after each feature extraction through convolution process, you are doing pooling operation. Pooling operation There are two types of pooling, maximum pooling and average pooling. Maximum pooling, you take in a small window, take the highest of it. You divide the whole picture into small square. In each of the square, find the highest value. Retain the highest value, discard the other value. This way, there is a dimensionality reduction. Accuracy goes down. Pooling, try to reduce the dimension, make the operation faster, but the accuracy goes down. And lastly, is used for prediction or classification. So this is the various part. I've given a cat, and my model CNN will tell whether it is a cat or no cat. So these constitute a convolution layer, pooling layer, and classifiers. These are the various neural network recurrent. I'll just tell you LSTM, a little bit of LSTM. LSTM, long short-term memory. You see this diagram. So these are the small model. And this model, yes, they produce an output. This is the forget gate. This produces out input gate. And this a set up small module. You delayed the previous information and feed. And by this process, you can get a long-term memory and a short-term. Short-term memory is a small delay or no delay. Long-term memory, that the past and past and past data you keep. And therefore, it is just like a recursive system where you can able to get the better performance. LSTM is a good example of performing better neural network which is used for deep purpose. Now this LSTM, I was talking about generative adversarial network. GAN. This, try to remember why GAN is important. Generator adversarial network. Whenever the amount of data is less, you do not have sufficient data to train a model, then in that case you have to use GAN. Generally, deep neural network requires large amount of data. But if the amount of data is less, or the data is imbalanced, one type of data is more, second class of data is less, artificial, the generator component generates more artificial data to make it balanced. So when for imbalanced data, the classification performance is poor, the generator adversarial network, by generating the artificial data, try to improve the prediction performance or the classification performance. So GAN comprise of generator and discriminator. So there is a generator and a discriminator. The radial basis, this is more layer, but basically it is a radial basis function. Simple Gaussian function is there, but the number of layers are 100, 200s, one after the other. Self-organizing map. This is most important, one of the very good technique. This map organized by itself is a type of unsupervised learning. And this self-organizing map is a very powerful deep learning model. It finds application, high dimensional data visualization, used for clustering, space approximation, etc. Restricted Boltzmann maze in RBM is another powerful deep learning model. This is a recurrent model. The learning process try to associate high probability with low energy. There is no intraday. And the advantage, excessive enough, expressive enough to encode any distribution faster than traditional bulge machine. Its activation of the hidden layer can be used to input to other models and enhance the performance. Restricted bulge machine. Similarly, deep billing network is another type of deep learning model. It introduces a solution to the problem of traditional neural network. Even though it is slow learning, it is based on probabilistic generative model. And this is composed of stacked layer of restricted Boltzmann machine. Restricted Boltzmann machine. Autoencoder is very powerful. You should try to use autoencoder. Basically, it is a feature extractor. Suppose I put a face here. This is a face here I put. And here the number of input nodes is say 1000. I bring it to very small value, like in a neural network, say it's about 10. So 1000 data is reduced to 10 data. And from these 10 data, I can reconstruct the face. So this part is called compressor. The second part is called expander. So whatever you give input, you should get the same out through proper learning. And once you achieve this target, then you give any features or objects or any ECG or EMG or any signal, you get a compressed value. Use this compressed value as the features into the prediction model, and you can predict or you can classify. So autoencoder, two parts, a compressor and an expander. Compressor is used to extract the feature and expander used to classify. Autoencoder is a very, very novel and very powerful deep learning techniques. The various industrial application ML/DL method, self-driving car, fraud news detection. It is extensively used in natural language processing, healthcare, entertainment, virtual assistant, fraud detection of development delays in children, smart agriculture, and so on. These are some novel application of deep learning. So these are some of the publications my group of students who are mostly in IT and NIT faculty. Our Satyasai Nanda is there in the electronics department of MNIT, who is my doctoral student. So these papers, if you look to, all are ACI journal paper. And this will give an idea about how much we are devoted to work. There are more than 200 papers on deep learning, machine learning. All are ACI papers. Nitin George is a faculty in IIT Guwahati. T. Panigrai, NIT Goa. Pyariman Pradhan, IIT Roorkee. All my students are in different IITs and NITs, and they've done very good work. And these works you can find, the details you can find by going to these papers, which are mostly ACI journal papers. These papers, you can see, I have given, we have used for active noise control, speech processing, image processing, a lot of application. You can find exchange rate prediction, stock market prediction. At least 8 to 10 of my students are directors, and they have done good work with all this. So this is, I make a overview of the presentation during 50 plus 50 minutes. Now I request the organizer to collect the question from the participants and they can display it here in the chat box. I'll go through and try to answer to the extent possible. But only I touched it. I never gone deeper into this. Not possible in 2 hours. But anybody who wants to learn more, my phone number, mail ID is there with the organizers. You can contact me offline through phone, through WhatsApp message, or through mail. I shall be very happy to pursue your research forward, give different concept, ideas, and guidelines. Thank you.
So much, sir, for your presentation. Now I open the session for question and answers. I request all the participants who have questions, please put out here. Anyone from the participants, please put out your questions. You can also write your questions in the chat box.
No question. Or you can directly ask.
Is there any other method equivalent to gradient descent method?
Yeah, I saw one question, Vinod Singh Jadhav. I am working on solar panel optimization. Which technique should be suitable to use? Question is, have you understood this solar panel? You are optimizing this solar panel for what? How many objective? Single objective or multi-objective? Two objective or single objective? What you are maximizing, what you are minimizing? Thermal storage. Maximizing one objective.
Shubham, the participant who want to ask the question, just unmute him or her.
Single maximization is very simple, but that cannot be published. It is actually two objective, three objective problem. You are maximizing what you are maximizing? Thermal storage. Is there any other method equivalent to gradient descent? That method is obsolete. Least mean square, recursive least square. These are the old method. They are likely to fall to local minima. Do not use. You can use genetic algorithm, particle swarm optimization, ant colony optimization, cat swarm optimization, honeybee algorithm. So these algorithm will not fall to local minima. You understand local minima? It is a multimodal problem. The all derivative based algorithm fall to look. It looks like we have achieved maximization, but they are not truly maximization. Such this problem encounter in derivative based optimization. Do not use. My request is try to understand GA, PSO, but these are old. Try to use cat swarm. Try to use ant colony. Try to use honeybee algorithm for solving your problem. No inbuilt function, don't use. Write your own program. take the help of some people. But if you use this inbuilt and try to solve, you can't change. No paper will be published. Try to understand the logic behind and this. Try to formulate your problem as a multi-objective optimization. Use multi-objective, the paper will be published. Do not use any inbuilt program or derivative-based law. Any other question?
Participants, if you have any questions, please raise your hand and we will unmute.
Any other question?
Participant, please raise the hand so that you can be unmuted for the query.
Okay. Is integer value problem for supervisory neuron optimization possible in MATLAB? Oh God, I see. Is integer value problem for supervisory neuron optimization possible in MATLAB? Yes, it is possible. Possible. Any questions?
Sir, why ReLU is so popular as an activation function?
Okay, there is no question. Okay, some more question. Okay. Writing.
Should I repeat my question?
Asking you. Which was this question?
Why
Meena-
ReLU is so popular as an activation function?
Why? Popular. Can you repeat your question? Meenakshi madam, can you repeat your question?
Sir,
Repeat your question.
ReLU, I found that in most of the papers, they are using the ReLU as an activation function, right? So my question is, why is it so?
ReLU. Oh, activation function. Let me tell you. Please listen. Most of our real life problems, whether it is forecasting, prediction, or clustering, or any types of modeling, is a non-linear problem. It is not a linear problem. Am I clear? For solving non-linear problem, the model should be non-linear. Artificial neural network without activation function is not linear, is a linear model. Therefore, every neuron contains sigmoid function, 10 hyperelic function to make the model non-linear. So that non-linear problem, non-linear prediction classification is possible. Second question, ReLU. If a data is negative, it makes it is also a non-linear function. But if the data is negative, the pass to the ReLU function, the output will be 0. And if you pass any positive value, 4 means output of ReLU will be 4. If it is input is 6, output will be 6. But if it is a -2, the output will be 0. So to remove negative values, ReLU is used. The sigmoid function or 10 hyperelic function is used in the neural network because it converts to nonlinear. The second reason why it is used, the derivative of this sigmoid function is continuous. It is not discontinuous. So if because in the backpropagation law you are using discontinuous function, you are using 10 Haberle function, so there is a differentiation in backpropagation law. That differentiation, the nonlinear function should be such that the derivatives should exist, 10 hyperbole and one-sided 10 hyperbole function or sigmoid function are continuously derivable. There is no discontinuity. Hence there goes. And ReLU is, even though nonlinear function, it is used to convert the negative value to 0. So both positive and negative values pass through ReLU, output always will be positive. Any other question?
Sir, in
Put
the
train a machine to learn itself, which algorithm is perhaps is a very new person. See, every model uses the old data, past data. For example, $1 is how many rupees? I know old. In January 1, January 2, January 3. So old information I use to train. Suppose you have to forecast the weather for last 1 year. What are the weather conditions? You know the input and out. Similarly, in a hospital, there are 100 patients. 60 people are having heart disease. 40 people are not having. You know the answer. So with the known data, if you train the model, that is called supervised learning. Now, first you train through a machine learning, and then all algorithm used for classification and forecasting, first you have to train, and once the model is trained, then you can able to perform it. The types of learning algorithm are different for each of the model. They are not same. First you have to train. Next question is in the domain of text processing, question answering. What is your question then? Ajay ji, in the domain of text processing, question answering, how to train a machine learning? Like chatting, yes. What you want to do? Your objective, I told you 8 operations: prediction, clustering, grouping, classification. To learn a chart machine, yes, first you have to train it. So it is any types of deep learning model you can use. With the old data, you train it. The model is trained, then it can able to chart. But if you have not trained with certain types of information, the fellow cannot chart. It is a dull system. Only whatever you have trained with that knowledge, it can chart. We human beings can chart anything by using our own brain, but a model cannot do it. That is the restriction. Perhaps one-to-one explanation would have been much better. Yes, if there is no question, if any more question, I have patience, I can
Sir,
see and say.
this side Sushant, just like as we optimize the non-linear algebraic equation, can we optimize the non-linear differential equation also?
They can send compile question, you can send it in my mail. Can we optimize?
Can we optimize the non-linear differential equation just
Yeah.
like as non-linear algebraic equation?
Differential equation. Can you, what do you mean by optimization, madam? Non-linear differential equation.
Once we solve the non-linear
Can
during
you
the
optimize means what? I couldn't follow your question.
basically when the differential equation
Differential
are
equation is always. You have to solve a differential equation. See, differential equation cannot be solved like this. You have to make an equivalent difference equation. Convert the differential equation to a difference equation. And that difference equation, you can use any types of machine learning model, particularly neural network, neurophage network, and you can solve it. You have to convert to difference equation. Try to learn how to convert the differential equation to a difference equation. Difference equation. Any other question? Okay, then thank you. If there is no more question, if anybody wants to give question, you can collect and send in my mail. I'll try to answer.
Thank you so much, sir.
Thank you, madam.
I would like to extend my gratitude to Professor Panda for sparing his valuable time today. We feel fortunate to receive such an educative and enlightening lecture from an eminent professor like you, sir. I truly feel that this knowledge will be useful in our respective fields. I thank all the participants for joining this session today. This brings us to the end of today's session. We will be meeting tomorrow as per the timetable. I request all the participants to make sure that they join the session tomorrow on time. Thank you so much.
Chemical reaction, yes, there are many examples. Pankaj Pandey, any example relate to chemical reaction engineering? Yes, you can predict. Suppose you mix 2-3 things. The model can predict what will be the output, whether it will be precipitated, whether it will be gas, whether it will be liquid, or color change, or what will be the output. You can do by chemical equation, but my model can predict. Intelligent model. So thank you finally. Thanks.
Thank you,
Thank
sir.
you for giving
Thank
me the
you.
opportunity. Thank you again.
Thank you,
Good
sir.
night to all.
Good night, sir.
Good night.